Hello friends, welcome to our channel Mechanical Motivator. In this video, we will be seeing determination of distance between the planes, magnitude and angular position of balancing masses. So this sum will be coming under the category of balancing of several masses in different plane. So here we will be having a shaft. A shaft carries four masses in parallel plane A, B, C and D in this order along its length. So order is A, B, C and D. The masses B and C are 18 kg and 12.5 kg. So mass of B and mass of C they have given and each has an eccentricity 60 mm. This eccentricity is nothing but radius. So RB and RC 60 mm convert into meter. The masses at A and D have an eccentricity 80 mm. So radius of A and D will be 80 mm. The angle between the masses B and C is 100 degree. So BOC will be 100 degree, and between the that between the masses at B and A is 190 degree. So BOA will be 190 degree. So they have given the two angles, both being measured in the same direction, either clockwise or anti-clockwise. In our problem, mostly we will be taking as anti-clockwise. The axial distance between the plane A and B is 100 mm. So distance between A and B is 100 mm and between B and C is 200 mm. If the shaft is in complete dynamic balance, determine the magnitude of mass A and D. So MA and MD we need to determine the distance between the plane A and D and angular position of mass D. So in this sum we need to determine 3 to 4 parameters, and this sum is slightly complicated but it's easy to do. So just listen as I say step by step. So from the question we can directly write the given data, and MA will be denoting the mass at A and MD will be denoting the mass at D. So first of all we need to determine the position of planes. For as they said, this is in the order of A, B, C, D. AB distance between A and B is 100 mm and B and C is 200 mm. He is asking us to determine the position of plane D from A. So distance between A and D. So we can take it as X. So X is the unknown. So I'm going to keep A as the reference plane because then only we can easily get the X value. So A as the reference plane and whatever values towards the right is positive. So we have drawn the position of planes. Next thing is we need to draw the angular position of masses. So first one will be horizontal, that is B. That is they are clearly given as BOC is 100 degree. BOC is 100 degree. So I'm going to keep B as the reference. So OB as the reference. BOC is 100 degree. BOC. So mass C will be at an angle of 100 degree from B. Horizontal line B. Next is BOA. So BOA is 190 degree. So distance angle between BOA is 190 degree. Keep the protractor in horizontal line of B and try to plot the masses A at an angle of 190 degree, and no need to worry about mass D, just leave as it is. After determining or proceeding the problem, we can easily mark the D also, mass D also. So angular position of masses we have drawn. Now we will be forming the tabular column. So first one will be plane. So A, B, C, D. In this A will be the reference plane and second tabular column will be the masses. We know the mass of B and C alone and mass of A and D is unknown. We need to determine. So MA and MD we need to determine. Eccentricity is nothing but a radius. So radius value we know. So once you multiply the M into mass into radius means we can easily get a centrifugal force. So centrifugal force divided by omega square, we will be getting the following value once you multiply tabular column 2 and 3. And if you want to determine tabular column 5, it's nothing but distance from the reference plane A. So just go back to the position of plane. So this is the reference plane, right? So just mark whatever distance it's from A. So 100 mm means 0.1 and 300 mm means 0.3. So likewise, if you mark, so A is the reference, that's why we are putting 0, and distance of plane D is X. So just measure from the position of planes and write the values. And last tabular column is a couple. If they divide by omega square means mr is the centrifugal force and L is the length, the distance from the reference plane. So mrl is just multiply the tabular column 4 and 5. If you multiply these two tabular column, you will be getting the couple values. And now look at the couple centrifugal force and couple among this which is having less unknown. See here we are having two unknown, but whereas here we are having only one unknown, so we'll be going with the couple only. But the only thing is we are having zero, which is a way which this value we won't be using, so it's a waste of time. We are having only two values which we'll be using in the diagram, so I'm directly going with the couple polygon. So angular masses we have drawn earlier. I mean, no need to draw again and again. If you draw once, it's more than enough. But just have the reference of the angular position of the masses. So first B will be horizontal, 0 degree, right? So couple polygon mean O dash, B dash, C dash. So B value, plane B is 0.108. So I'm going to use the scaling. So 1 centimeter will be 0.03 kg meter square, because it's couple polygon, right? So unit is very important. Couple means kg meter square, and centrifugal force means kg meter. And 0.108 divided by 0.03 means you will be getting 3.6 centimeter. So keep your scale here and draw 3.6 centimeter line, and this is B, mass B. This line will be denoting the mass B. And next is C. C value is 0.225. 0.225 divided by 0.25 means you will be getting 0.225 divided by scaling is divided by 0.03 means you'll be getting 7.5 centimeters. Scaling its our own wish, we can keep any value, but try to have a whole number for making it for it will be very easy for us to draw. So 7.5 centimeter. So we know the length of the mass C, it's 7.5 centimeter, and angle is 100 degree. So for 100 degree, draw a line for 7.5 centimeter, and for 100 degree draw a line, and that is the point C. Now remaining this is unknown, and this value we can't use, so just close the polygon. The closing of the polygon will be giving the resultant value. The resultant value is nothing but 0.08 mdx, but here there are two unknowns, so it's very easy, it's very difficult for us to find, but just keep as it is. So now join after joining in, this is in dotted line, and try to put the arrowhead. It's going like this, and arrowhead is very important, and try to measure the angle. So if you measure means you'll be getting 253 degree. So this line will be denoting the mass D. Now we have determined the angular position of mass D, which is having a 253 degree. So try to plot it in the angular position of masses. So now plot the value of D for 253 degree. Draw the mass D. So if you measure means O dash C dash, you will be getting 7.8. So this is nothing but a resultant, right? So resultant is 0.08 mdx. So write as it is. 7.8 into scaling factor we divided by 0.03, right? So we need to multiply into 0.03. So you'll be getting a value of 0.234. But a problem here is md and x, both the values are unknown. So keep as it is, and later on we'll be solving this. Now go for the force polygon. So force polygon, we know we are already having this diagram. Force polygon, the problem is here also we will be facing one issue. That is, here are two unknowns are there, but we know only two values. So with the B 1.08, right? So draw that line. So OB means it will be parallel to mass B. So it's one scaling is 1 centimeter is equal 0.25 kg meter. So 1.08 divided by 0.25 means we'll be having 4.3 centimeter. So 4.3 centimeter, draw a line here. So 4.3 centimeter, draw a line, and this line should be parallel to the mass B. So 4.3, you have drawn the line. Next thing is C. C for this mass C, we know the angle, that is 100 degree. We know the angle 100 degree, and value also 0.75. So for plane C, it's 0.75. So 0.75 means 0.75 divided by 0.25. You will be getting 3 centimeter. So for 3 centimeter and 100 degree, draw a line. So you'll be getting the point C. 3 centimeter, 100 degree, draw a line, you will be getting the point C. Now try to come back to the angular position of masses. That is, this mass D, you know clearly that it's 253 degree. So it's 253 degree means try to draw a line parallel to the mass D. So this line should be parallel to this line. So try to understand, try to draw a line keeping your scale on angular position and try to move the scale towards the force polygon and try to draw a line parallel to some certain distance. Now this line will be denoting the mass D and this line will be denoting the mass A. So we know the mass A, right? It's 190 degree. So here try to draw a line 190 degree. For 190 degree, try to draw a line and extend to certain extent, and these two lines will intersect at a point, and that point is called D. Once again I repeat, this line will be denoting the mass D. So mass D, try to keep your scale and try to move towards the force polygon, draw a line to some extent, and this line will be denoting the mass A. So mass A, it's 190 degree. So for 190 degree, try to draw a line to certain extent, and these two lines intersect at a point, and that point is called D. So now we know clearly that this line will be denoting the mass A and this line will be denoting mass D. So coming back to the tabular column, so A is 0.08 MA. So write 0.08 MA and D is 0.08 MD. So in D you write 0.08 MD. So now measure C and D. If you measure C to D means you'll be getting 2.9. So just multiply with the scaling factor 0.25, you'll be getting 0.775. So 2.9 into 0.25 means you'll be getting 0.7. 2.9 into 0.25 means you'll be getting the CD value 0.775. So now we know clearly that this value is nothing but CD, right? So CD 0.775 will be 0.08 MA. So here only one unknown is that we can easily determine the MA value. The mass of A, it's 9.68 kg. Next measure O to D. So if you measure O to D, you'll be getting 2.8. Then multiply 0.25, 2.8 into 0.25 means you'll be getting 0.7. So here you will be getting 0.7, and here only MD is unknown. That is OD means 0.08 MD. MD is the unknown value, so we can easily calculate the mass of D. So you'll be getting 8.75 kg. MD value is 8.75 kg. So now we have determined the mass of D. Now going back to the coupled polygon. Here we know the mass of D as 8.75 kg. So now substitute MD as 8.75 and try to determine the X value. Take everything to the left hand side. So 0.234 divided by 0.08 divided by 8.75, you will be getting 0.334. So approximately 0.33. So X value is 0.33 meter. Now we have determined the distance of the plane D from A. That is X value 0.334 meter. So we have determined all the things which in the question, which whatever they asked us, we have determined it. In case if you are having any doubt means type in the comment section and try to solve as I say, as I instruct. If you keep on drawing means you will be getting the exact answer. And even though even then if you are having doubt means you just tell which place you have stuck or whichever point you don't understand means, so that I can the tell in a clear way in the next upcoming videos. Please do subscribe to my channel Mechanical Motivator and press the bell icon. Then only you will be getting all the videos which I upload, and try to share with your friends so that they will also be get benefited. Thanks for watching this video. Have a great day.